Hi everyone, Frankie from easypowerwall.com. If you wonder if I'm leaving solar for gardening, don't worry. I'm still full into solar. But there's a new project coming up. I will replace these not so old 280 watt peak panels by 440 watt peak panels. Technology changed a lot over the years and panels are dirt cheap today. So this will be another DIY step-by-step instruction video on how to replace these old panels by a new technology. A few weeks in advance I started looking for solar panels that would suit me best. I ended up choosing for Yaso 440 watt peak bifacial panels. Yaso panels are tier 1 panels. This company is even listed or was listed on Nasdaq. The panels were shipped 2 days later and in my possession. Price for these panels was less than €600. Clamps for these panels were not available from the solar reseller, so I ordered them from a local company and got them a few days later too. I needed 16 clamps and 8 end clamps. I was down a little over €50. Next item to check is the breaker from the combiner box. This build will be a 3S3P configuration, so the power of 3 strings goes through the combiner box. Let's check the datasheet of the solar panel. A little over 13 amps. Maximum current for 3P config is around 40 amps. If you perform a significant upgrade, you might have to replace the breaker. To calculate the breaker from the battery, we take the total power, in this case close to 4000 watts, and divide by the lowest possible voltage, 48 volts. We get a little over 80 amps. For my ground mount solar system, I created an area at the bottom of these solar panels to get rid of excess of water from these panels. This keeps the area mud free and my battery health happy. New panels are longer, so I had to dig up my gardening skills and move the concrete border about 15 cm. Of course, I'm not gonna bother you with this, so fast forward to the solar project. When working on solar and batteries, safety is a very important topic. Before we touch the solar panels, remove the wires, it's very important to cut the power from the solar panel. So I will remove the DC power from the solar panels, but I will keep the batteries connected to the MPPT charger. As you noticed, I have a second MPPT charger. This is for the solar on the shed, and I don't have to remove this power. This can remain in service and charge the batteries while we work on the other solar panels. And I already cut the breaker at the MPPT charger, but I also will remove the breaker here at the combiner box. And now we can safely remove all cables. As you can see, there are a lot of wires under the frame. I had to extend several cables to the combiner box. If you remove these cables, be very careful that they don't touch the ground, that they don't get any moisture or sand into the connector, so that we can reuse them later, maybe to connect the new panels. This is an MC4 spanner, and we need to use this tool to undo the MC4 connections. The MC4 connectors are connected via 2 levers with a barb. The connection is rock solid and watertight. To disconnect the connector, put the MC4 spanner over the 2 barbs and pull the plugs apart. Link to this tool under the video. It's a dirty job, but someone's got to do it. For today's project I got some help from my assistant Keanu. I remember from the initial build it was pretty difficult to align the panels with the surface and the frame, so we decided to keep the existing alignment. We removed the solar panels from the top row first and replaced them by the new ones. We loosened the old clamps by hand, but if you have the right hex bit you can use an impact drill too. We took our time to remove all panels to make sure we didn't scratch or damage the panels. Once the project is finished, we can reuse or sell them. Make sure you don't lose any bits from the clamps. We used a separate box to collect these pieces. Once all panels were removed, I gave the frame a good wash. This to avoid scratching the new panels when I moved them over the rails while adjusting them to the right position. Before I install the new panels, let me show you the major changes solar panels have been going through the last few years. First of all, physical appearance. Panels are longer and wider. Smaller edges between cell and frame. Efficiency increased to 23%. To reduce the weight, the width of the panels is now 3 cm compared to 4 cm for older panels. The biggest change is under the hood. Let me turn both panels. Most panels are bifacial. This means panels generate energy from reflected sunlight to increase efficiency. I have seen YouTube movies where they claim a gain between a few percentages up to 8%. Another milestone solar panel makers achieved is the half-cut technology. Each panel is divided in 2 panels. That's why they call it half-cut. If there's shade on one half, the other half works and doesn't impact the whole panel or string. Installing the panels isn't that difficult, especially for a ground-mounted system. All panels are moved to the frame. Between every panel there's some spacing. This allows you to install the clamp and move the panel. Start with the first panel and an end clamp and work your way to the end. Give the end clamps a good push and they will click into the mounting rail. With a clever design, these clamps won't come loose. Did you notice that not only solar panels faced redesign? Also these clamps are much smaller and lighter. Weight ratio is 3:1. As you see, we really enjoyed the father-son weekend project. While Keanu installs the end clamps, I start loosening the clamps from the bottom row. After the delicious meal, we continued removing the panels. The removal of these lower panels is even easier. I gave the rails a good wash and in no time we were ready to install the first panel. And to make the first mistake, that will show up in a few moments. As with the first row, start with the end clamps. I kept a gap of 1 mm between the top and the bottom row. Once the first panel is installed, you install the clamp to the first panel and add the second panel. There's absolutely no rocket science involved, and not much that can go wrong. After installation of panel 2, the assistant had to leave for an hour. This allowed me to check the installation from the other side of the frame and to discover the error. The goal is to connect them in the L configuration, and now I noticed that one panel, I all face them in the same direction, so with the female connector. But if I want to connect this panel with the panel at the bottom, I also have the female connector there. So I think I'm gonna have to remove the 3 bottom panels and twist it 180 degrees. So learning from my mistakes, make sure to check the configuration and make sure the connectors line up with your configuration. Once my assistant returned, we flipped the second panel 180 degrees and we were good to go again. In no time we added the rest of the bottom panels, and with the end clamps in place and well tightened, we could enjoy the new look of our solar installation. So this is the new solar array. 10 panels installed. It will be installed as a 3S3P configuration. Thanks again to my assistant Keanu. Great job, man. Thank you. Next step, installing the panels. A few days ago I connected all the panels. Sadly enough, I was alone, so I couldn't record the whole process, but I will give you some tips and tricks how it should be done. So let's have a look at the other side of the panels and see how I've done the wiring. Wiring depends, of course, on your configuration. I have a 3S3P configuration. I will show you a picture how I configured the panels. I try to avoid that these cables can touch the frame, so it's protected with some piece of rubber. I use the inner tube of a bicycle tire. The same here for the frame. I try to avoid that the cable touches the frame, so I put some rubber between it. If you don't have this inner tube, you can also use shrink tube, but this is reuse and I like to reuse things. Let's go down a little bit. Same as with the upper connector. I have some, this is a piece of shrinking tube. So it's protected from rain, sand, because these chickens, they make a lot of dust. So the connector is well protected. Same here, the cable is protected from the frame. I did this in the past and I never had any issue, no arcing. Same there. You see even the chicken doing its job. You see they create a lot of dust, especially in the summer. So I protect the cable and the connector from the sand. This will make it a lot easier if I have to remove the connector. But let's hope I don't have to remove these connectors in the near future. Sadly, the old brown chicken died a few days ago and I decided to go for a white one. So it will maybe create some or reflect some sun to the bifacial panels and create some extra energy. By the way, these white chickens, they have a smaller CO2 footprint, eat less, and they produce bigger eggs. So everyone should go for a white chicken. In this situation, the connector is well protected from the sun, water and dust. And if there is coming water through the gap, it never can reach the connector. Water drops from the cable to the sand. The frame is connected to the earth. There's an 8-meter pin going into the ground here. I live in an area where there's not too much thunderstorms, but the frame and the combiner box have a connection to the earth. The panels are not connected to the earth. They are of course connected via the frame, but I don't have a separate connection for the panels. Should I do it or not? I'm not really sure. I'm not an expert, so maybe let's use the comment section under the video. Are you an expert and can you give me some advice? Please do. You probably noticed that panel number 10 is still not connected. If you want to know what I'm going to do next with this panel, just subscribe to the channel. Results are great and they meet all expectations. Last few days were very sunny and the 9 shed panels plus 9 garden panels generated over 27 kilowatts on a daily basis. Still early spring here, but today I set a record for 2025 with 28.6 kilowatt hours. Maybe that number doesn't say much, but it compares to adding 150 kilometer or 100 miles of range to your EV. Isn't that great? This year I break the magic barrier of 40 kilowatt hour on a sunny day. Thanks for watching the video. See you soon for more content on easypowerwall.com.